All right, now that we took a look at how to find the vertex or the axis of symmetry, and depending on the value of A, if it's up or down, I can go ahead and make some conclusions about this right off the bat, right? Notice that my A value, in this case here, A is equal to -2, B is equal to -4, and C is equal to -3. C is equal to -3. But in our previous video, we went over the A value. If A is greater than 0, then it opens up, right? If A is less than 0, it points down, right? It opens down. So in this case here, I can already make a conclusion about one of these features, right? This one right here, it opens downward. And since it opens down, that means that I'm going to have a maximum. I don't know my maximum value yet. I don't know my maximum value yet, but that's what we're going to go ahead and find. All right, I'm going to find my axis of symmetry. Like I said before, it doesn't have to be in any specific order. It's depending on the order that you want to go about it, right? Since I know how to find the axis of symmetry, I'm going to start with that. Okay, so my axis of symmetry, okay, x equals to something, right? But I know that x is equal to the opposite of b over 2a, right? I haven't done any of these calculations, so I'm going to do them as if you were doing a problem as well. Okay, so I'm going to go back and forth. Okay, so if you don't have to go at the pace that I'm going, right? You have the liberty of pausing this at home, so that way you have all of this written down, and then continue playing it once you have it all down. You don't have to go at the same pace as I am, right? So with that said, let's go ahead and let's figure some of these out. Okay, so x is going to be equal to the opposite. Anywhere there's a variable, I'm going to put parentheses. Okay, that way I get the correct values. Okay, so b is -4 all over 2 times -2. Okay, and I'm going to go ahead and enter it exactly how I see it here. Check it out on my calculator. I'm using the scientific calculator from Desmos. I recommend using this one, right? It makes it a lot easier and clearer for me. Okay, anywhere I see a variable, I'm going to put a parentheses all over 2 times -2. This right here is going to be -1. So this right here is equal to -1. So my axis of symmetry, x equals -1. So I'm going to go ahead and put that right here, x equals -1. Okay, so I'm going to draw that right over here. So x equals -1. So all of that right there is equal to, that's x equals -1. So I'm going to write it right up here. X equals -1. Oh, check it out. Take a look. X equals -1. So I have that there. Okay. X equals -1. So now that I have the x coordinate for my vertex, right, I can just go ahead and write that for now. -1. I know my vertex is going to land, it's going to be somewhere on that axis of symmetry, right? This is my axis of symmetry, and it's like in it's an invisible line, for lack of better words, right? That notes the center of my parabola, the middle of it, where if I were to fold it in half, each point on every side of that axis of symmetry will line up for any given quadratic. Okay, so my vertex, I'm going to go ahead and I'm going to separate my work. I did that in purple, so my vertex, I know my x coordinate is -1. All I have to do is take my original equation, which is this one right here. Okay, and anywhere there's a variable, I'm going to go ahead and leave space right in there for my value. And it's -1 here, That's a square times -1. So, like I said, I'm going to go ahead and enter it just as I see it there. -1 squared minus 4 times -1. Close that up, minus 3. And we get that is -1, right? All this right here, y is equal to -1. So my vertex is at -1, comma, -1. So -1, -1, right there. That's my vertex, right? That's my vertex. Now that I have my vertex, okay, now I know that it has a maximum of -1. Okay, maximum of -1 at x equals -1. Okay, perfect. Now let's go ahead, let's find the y-intercept. Okay, my y-intercept, we'll do that in green. Okay, I'll do that right here. Y-intercept. I'm going to abbreviate it. And that's the value of y when x equals 0, right? When x equals 0. So I'm going to take my original equation, 2 times whatever squared minus 4 times whatever minus 3. And then that whatever is going to be this value of x of 0. So 0, 0, okay? And I'm going to go ahead and use this one right here, -2 times 0 squared minus 4 times 0, close that up, minus 3, and we get that it's equal to -3. So my y-intercept is going to be 0, -3. Okay, so y-intercept 0, -3. All right, 0, -3. Now, what I can do with this here, since I know that this is going to open downwards. Okay, this is going to open downwards, and I know that this is symmetrical, right? Since it's a parabola. So I know that I don't have to do anything else to find any other points. Now this is going to be a sketch using these 3 significant points. Once you get your significant points, you don't have to um, continue drawing this or finding other points unless you really want to. That's up to you, right? But for me, all I want is I want you to be able to see that, oh, okay, we don't have to continue this anymore. Okay, sometimes you won't be able to see the y-intercept, and that's okay. Okay, that's okay. I still want you to state it, but notice here that that there are no x-intercepts. So I'm going to go ahead and put no x-intercepts just to be specific. Okay, we'll go ahead and take a look at another one in just a bit. So um, be sure to get all that work down. Now, if you're wondering why we don't have any x-intercepts, if I were to go ahead and do the quadratic formula for these here, my radicand will be negative, and we know that we get 2 complex solutions in that situation. So that's why I don't necessarily have to calculate the values of x as solutions to this quadratic, because we already saw that it opens downwards, and that will be my quadratic for this one right over here, or the graph for this quadratic. All right, let's go ahead and let's take a look at this quadratic here. Okay, I'm just going to go ahead and take a look at my values of a, b, and c. A equals 1, b is equal to -2, and c is equal to -1. Since a is 1, 1 is greater than 0, I know that this right here is going to open up, right? It's going to open up. That means that if it opens up, it's going to look like this, right? Which means I will have a minimum at some point. I don't know that point yet. At some value of y for that value of x. Let's go ahead, let's find the axis of symmetry for this one right here. Okay, so axis, I'm going to go ahead and abbreviate it and work fast through this one. Okay, my axis of symmetry, x is going to equal to some value. Okay, and we know that x is equal to the opposite of b. Okay, the opposite of b all over 2 times a. Okay, so let's go ahead, let's figure out what this is. A right in here is going to be negative 2. Close that up, 2 times 1, and we get that x equals 1. So for my axis of symmetry is going to be right over here at x equals 1. Okay, it's going to look something like that. All right, so my axis of symmetry, x equals 1. My vertex, I know my x coordinate is going to be 1. Okay, vertex is going to be 1 something. So my vertex is going to be y equals 1 squared minus 2 times 1 minus 1. And if we calculate this right here, we get 1 squared minus 2 times 1. Close that up, minus 1. We get negative 2. So our vertex is going to be at 1, negative 2. All right, so at 1, negative 2, right over here. Okay, so now that we have that right there, 1, negative 2, I'm going to switch it up colors just so that way we have some variety. Okay, so I have a minimum at negative 2 when x equals 1. And I got that from right over here. It's a vertex, right? My y-intercept, let's find my y-intercept. Y-intercept, that is a value of x, or excuse me, the value of y when x equals 0. So y equals 0 squared minus 2 times 0 minus 1. And if you were to calculate all that, we get y is equal to negative 1. Okay, so this is 0, negative 1. Y-intercept, this is 0, negative 1. Bam, 0, negative 1. And we have that point right there. Now notice this will have solutions. This quadratic will have real solutions. And so let's go ahead and let's figure out what those values will be. So x equals negative b squared. There's my x-intercepts. X equals negative b squared plus or minus the square root of b squared minus 4ac all over 2a. This is my quadratic formula. Okay, so I'm going to go ahead and find out what my x-intercepts are. Okay, so I will have x-intercepts in this situation. Okay, I don't know if you guys heard it, but there was a train that passed by, so I paused it really quick. But you probably didn't know that. Right over here, I accidentally put minus b squared, but it should be just minus b, so I crossed that out. My values of a are 1. My value of a is equal to 1. Value of b is equal to negative 2. C is equal to negative 1. And I'm going to use those values here to put into my quadratic formula. This right here is 2 plus or minus the square root of all that. I'm going to find out what my discriminant is. And I'm using parentheses wherever a variable goes. That is important. I've seen a lot of us that we didn't make that correction, so you ended up with incorrect values. So this right here is going to be the square root of 8 all over 2. So x equals to 2 plus the square root of 8 over 2, or x is equal to 2 minus the square root of 8 over 2. So I'm going to go ahead and put that right over here into my calculator. 2, actually I'm going to do this first. All right, 2 plus square root of 8 all over 2. So this one right here, x is approximately, I'm just going to use 2.4, 2.4 round to nearest tenth, or x equals, same thing, but now we're subtracting. X equals negative 0.4. Okay, so my x-intercepts are going to be 2.40 and negative 0.40. Okay, so right over here, 0.5 is around there, 0.4 right over there, and 2.4, this is 2, 2.5 right there, 2.4 right over there. And I'm going to go ahead and bring all of those together. There we go. Oh, and there we have it.